Hail is one of my favourite phenomena to photograph, although it's not always the most pleasant to be out for obvious reasons. Hail can be small, medium or large, and it can be mixed with rain or just fall by itself. And it forms when moist air rises up and condenses into water droplets, but there is sufficient warm updraft in the storm for them to rise high above the freezing level and then freeze. This occurs when warm air that forms clouds is fed through large updrafts. The droplets circulate around in these clouds, freezing and gathering layers and growing in size. The larger the updraft, the more hail these clouds can hold before gravity ultimately takes over and the hail falls to the ground. Now, if you were to cut open a large hail drop, you can actually count the number of rings to see how many times it's been up and down in this cloud. In the cloud, the winds are in all directions, so the developing hail gets thrown around, cast out, or even clumped together before gathering more ice and becoming supersized. And hail falls when the updraft weakens, or when it becomes too heavy to remain in the cloud. Often, the larger hail falls near the updraft, as it can overcome the power of it, and smaller hail can be blown away by horizontal winds in the storm. Do you ever wonder why we still have hailstorms in the summer? Well, winter or summer, we have unstable weather patterns that create showers, and they're what lead to hail. But in summer, we have more energy in the atmosphere to create these big thunderstorms, and therefore updrafts can be much larger, resulting in hail keeping on moving up and down through these layers in the cloud for much longer, gaining layer upon layer of ice. The stronger the updrafts created by the storms, then the larger the hail can grow. Now, in the UK, the largest recorded hail was around 6 centimetres in diameter and weighed about 200 grams. And we're lucky here in the UK that most of our storms don't grow large enough. But in places like Florida and other areas of the US, the storms that develop are much larger, and hail can cause severe damage to property and farmland. The largest hailstone ever recorded was around 20 centimetres diameter, weighing about 0.75 kilograms, which is about most of a bag of sugar, and reportedly hit the ground at 100 miles per hour, so it puts it into perspective really. So in the UK, we get most of our hail in winter. It tends to be along the west of the country. Remember, the sea has a higher specific heat capacity than the land, meaning it holds temperature much longer than the ground, and therefore is warmer than the land in winter. Therefore, showers tend to form out at sea, where they're supplied with warm, moist air, and then blowing westerly, inland to the east, due to our prevailing wind directions. And as these showers develop, moist air can be driven up, creating this hail. So these clouds are driven by the warmer air, and once they start to pass over the colder land from the west, they can lose a lot of this energy and dissipate quite quickly. And this is why it tends to be in the western regions only in winter. Now, many of the best hailstorms I've actually ever photographed have been between April and May, when in spring, the general temperatures are pretty much still low enough for freezing temperatures to be close to the ground. And the ground is still warm or mild enough to enable these showers to actually form across the land. And this gives us hailstorms further inland, such as this one shown here, which was taken in the Peak District, which is pretty much one of the most inland places of the UK. In terms of predicting this sort of weather, the weather apps really do all the hard work for us. But remember, stormy clouds can occur when a cold weather front catches up to a warm front and forces the moist, warm air above it. So you can get an idea ahead of time if we might have the right conditions for hail by looking at our weather fronts, such as on Ventasky. However, Ventasky, Clear Outside, Met Office and other apps pretty much will just report hail on the forecast if the conditions are right. What we then have to do is consider how to witness it, as you'd rather be stood across a vista looking at it than directly under it being pelted by it. Although, if you are actually out photographing it, the latter probably is quite difficult to avoid. Therefore, I'd always recommend looking at Ventasky and looking at where the forecasted hail might be passing by or the direction which it's moving in, and then selecting a view large enough to enable yourself to safely witness the storm from afar. Cowlow Barn near Castle in the Peak District has pretty much been my go-to location for many years in terms of witnessing hailstorms. It's on top of a hill looking north across a valley, which in general would have a westerly wind to blow the storm across the scene. Although I will admit, these photographs here were taken at the start and end of a passing hailstorm. Each time I did have to shelter for a period because, as you can expect, this is not an exact science. So how do you differentiate snow from hail? Well, to recap, hail is created when moist air condenses as rain droplets and then moved into a storm by warm updrafts and then supercooled to form ice pellets. So what makes it snow is when the ice crystals form inside the cloud above freezing level, rather than being first a droplet and then freezing. This is similar to the differences between deposited frost and a freezing dew that we've talked about earlier. It's about their original state. Then, as ice crystals forms in the cloud, they stick to each other and create the intricate snowflakes that we're all so familiar with. Now, we've seen already how these are represented on the forecast, but to recap from earlier sections, the Snowfall tab on Ventasky allows us to see the total depth of snow at a location and the anticipated new snowfall for a period. If snow is on the forecast, then this will be shown as a snowflake icon on Ventasky or Clear Outside instead of a rain icon. I find switching between the two sets of data useful to see what snow is forecasted, as well as understanding how much snow we may already have on top of the mountains. And then this allows me to better plan my hikes, photos, etc. accordingly. I find that once the snowy front has passed and it's had a day or two on the ground, it's perfect for photographing, as the wind will have created drifts or textures in the snow. So try looking for obstructions to the wind, such as large tufts of grass, mounds or walls that will interrupt or shelter the snow from the wind's path, as these are what lead to these more interesting patterns that make for great photos. This image was taken in the Peak District overlooking a place called Crome Hill. You'll notice these textures in the foreground and a small cornice or ledge of snow against the wall. On the other side of the wall, it's even more interesting, where an even larger cornice has formed due to how the wall has interfered with the wind after the snow has fallen. So that concludes this section into the development of hail and snow. Although the weather apps and services here quite simply tell us when we have snow or hail on the forecast, it's important that we understand the principles of how they form. This is always useful when trying to plan a photograph. For example, knowing why spring and early summer often lead to bigger hailstorms, and then bearing this in mind ahead of time so that you're ready to go at a moment's notice.